Lesson 6.5, Indirect Proof and Inequalities in Triangles. So an indirect proof is a method for proving things where it's too difficult to actually make a proof. So what we do is we actually prove that the opposite is impossible. So let's say we're trying to prove something is true. Well, maybe there's no way to prove it's true. So instead of proving it's true, we prove that it cannot be false. Well, if it is impossible for it to be false, then what that means indirectly is that it must be true. So, with that said, an indirect proof, you make an assumption, basically for the opposite of what you're trying to prove, and you're going to prove that the opposite can't happen. We'll do a couple in just a minute. The triangle longer side theorem and the triangle larger angle theorem. Essentially, if you have a triangle, this is a bigger angle. It's wider. It would have a bigger degree. So here is the longer side. Notice that the longer side is across from the bigger angle. So here's kind of an example. You get a pair of scissors. You guys know how this works. As I open up the scissors, the angle is getting bigger, right? So here it's really skinny, and here it's a much bigger angle. The side opposite the angle would be this distance here. As I make this angle bigger, the side gets bigger. When I make the angle smaller, the side gets smaller. You guys know this in the sense of scissors. You use this all the time. You might open them wide if you have something big to cut. You might close them smaller if it's something skinny to cut. It's the same thing here. Bigger angles make longer sides. Bigger angles make longer sides. Longer sides make bigger angles. And the reverse, smaller angles make smaller sides, and smaller sides make smaller angles. The third one, the triangle inequality theorem. The sum of the lengths of two sides must be bigger than the length of the third side. So if you have a triangle, let's say that was 2, 1, and 3. Those were the side lengths. In order for this triangle to exist, the two shorter sides have to add and be bigger than the longest side. Is 1 plus 2 bigger than 3? No. So that triangle wouldn't exist. And here's kind of an exaggerated option. Let's say this was 10, and this was 2, and this was 2. Is 2 plus 2 bigger than 10? No. That triangle also won't work. But kind of think of it this way. Think if this was like feet long. This side is 10 feet long. This side is 2 feet, and this side is 2 feet. What's the furthest that you can reach with 2 feet and 2 feet more? The furthest you would be able to reach would be 4 feet. You're not going to be able to reach 10 feet distance. Your triangle would actually look more like this. The 2 and the 2 would not be able to meet because they're too short. So in order for the triangle to exist, it would need to have, say, a 10, an 8, and an 8 would work because 8 plus 8 is bigger than 10. So that one would work. The two shorter have to add up to be bigger than the longest. They cannot be equal. They have to be bigger than. So let's look at example 1. Given triangle ABC, prove triangle ABC can have at most one right angle. This is the proof of why triangles cannot have two 90-degree angles. So what we do is we say, let's assume triangle ABC has the opposite of at most 1. At most 1 means 1 or less. So let's assume that triangle ABC has two right angles. So instead of saying assume that triangle ABC cannot have at most, you're negating it by saying the opposite of at most 1. The opposite of at most 1 is more than 1, so we're going to say 2. Let's the measure of angle A equal the measure of angle B, which equals 90 degrees. Those are the two right angles. Then, the measure of angle A plus the measure of angle B plus the measure of angle C, if you add up all three angle measures, you should equal 180. So, substituting in 90 plus 90 plus the measure of angle C equals 180. Then, the measure of angle C would have to be 0. This is not allowed. So what we assumed that A and B were both 90. What we found out is that if A and B are both 90, then C has to be 0, and that's not allowed. This is a contradiction. So what that means is that our assumption was wrong. So, triangle ABC can have at most one right angle. And it's very proof by contradictions to me are very uncomfortable because you're trying to prove something that you know isn't going to work. And you know that you're going to hit a dead end, and you know that you're going to run into problems, and you still proceed, and the problem is what you want to run into. So you go until you hit a problem, and then you say, so what I did was all wrong, which means what we were trying to prove had to be true. So example 2. Write the first step in an indirect proof of the statement. This is all we really expect you to be able to do, is to write the first step and to show what sort of thing is a contradiction. We don't expect you to be able to write the whole proof. So let's look at 2A. Not all students in a given class can be above average. Assume the opposite of that. Assume, what is kind of the opposite of not all students? Assume all students in a given class can be above average. That's what we're assuming. Number 2, no number equals another number divided by 0. Assume the opposite. Assume that it's wrong that no number equals this. So what we would assume there is a number that equals another number divided by 0. Number 3, the square root of 2 is not equal to the quotient of any two integers. We would assume, instead of the square root is not equal, we would assume the square root of 2 is equal to the quotient of two integers. So you're just assuming the opposite of what they say. Now, example 3, determine which two statements contradict each other and explain your reasoning. So in example 1, there's A, B, or C. Two of these cannot coexist. There are two of them that cannot happen at the same time. So let's look. Triangle LMN is equilateral. That means LMN that all three sides are equal. B says that LM is not equal to MN. Well, right there, I think we found a contradiction. Because A says that all of the sides are equal, and B says, no, they're not. Those can't both happen at the same time. Now, it is possible to have all three sides equal and also have angles equal. Because remember, if the sides are equal, then angles are equal. A and C don't cause a problem, but A and B does. Number 2, triangle ABC is a right triangle. Angle A is acute and angle C is obtuse. So here's a right triangle. ABC. Is it possible to have a right triangle and have one of the angles be acute? Yeah, this could be a 40 and a 50 and a 90. Is it possible to have it be obtuse? A 90 and a 100. That doesn't work. And the reason that doesn't work is because if you have a 90-degree angle and you have something more than 90 degrees, then you add up to more than 180. Now, it is possible to have an acute and an obtuse angle. Maybe like this. Angle A is acute and C is obtuse. Those two can coexist, but A and C cannot happen at the same time. Example 4. List the angles of the triangle in order from smallest to largest. Small to large. So the small, the medium, and the large. The smallest angle is across from the shortest side. So which side is the shortest? That's the 6. Now go across the triangle. That's angle C, is the smallest. Which side is the next smallest? The next smallest is the 8. Go across the triangle. That's angle A. And the last one has to be angle B, because B and 10 are across from each other, and 10 is the longest side. Let's do it again with GHJ. The smallest angle is across from the shortest side. The shortest side is 11, so across from that is angle H. The next shortest is the 14. It's across from the J. And the 16 and the G are the last. Example 5, is it possible to construct a triangle with the given side lengths? Why or why not? We're not looking for a super complicated answer here, but we are looking for more than just yes or no. So remember, what you do is you add the two shorter sides, and they have to be bigger than the longest side. So which ones are the shortest, the 3, 17, or 12? The 3 and the 12 are the shorter. and they need to be bigger than 17. 3 plus 12 is 15 bigger than 17. Is 15 bigger than 17? No. And this is your explanation. 5, 16, 21. Which ones are the shortest? 5 and 16 need to be bigger than 21. 5 plus 16, 21 is bigger than 21. Not true. 21 is equal to 21, but it is not bigger. 8, 5, and 7, which ones are the shortest? 5 plus 7 needs to be bigger than 8. That's 12 is bigger than 8. That is true. So yes, that one does exist. And the last one, add the two smallest, the 10 and the 3. 10 plus 3 is bigger than 11. That's 13. Sorry, is bigger than 11. That is true. And with this, you should have enough information to do your homework for section 6.5.